Hi, my dear students. Myself, Prasanna Kumar, Assistant Professor, Department of Electronics, Sri Ramakrishna College of Arts and Science, would like to handle a session on vertical sync separator. This topic is related to audio video communication subject. The vertical sync separator is a circuit designed with the help of low pass filter. The circuit arrangement is shown in the video. The transistor Q1 acts as a emitter follower. The transistor Q2 acts as a sink separator. The output of transistor Q2 is fed as an input to the low pass filter to produce vertical pulse. The same output is fed as an input to the high pass filter to produce horizontal sink pulse. According to the time constant of resistor R1 and C1, vertical sync pulse is created and it is applied to vertical oscillator. According to the time constant of capacitor C2 and R2, the horizontal sync pulse is created and it is applied to automatic frequency controller. The input to the circuit is a composite video signal that is applied to the base of transistor Q1. The emitter output of transistor Q1 is applied to the base of transistor Q2. The output obtained across the collector of transistor Q2 is fed as an input to the low pass filter. According to the time constant of resistor R1 and C1, the low pass filter will produce a vertical synchronizing output that is fed as an input to the vertical oscillator. This circuit is arranged in such a manner to produce an synchronizing pulse output at the transistor Q2 and that is given to the two circuit to produce or to separate the synchronizing pulse of vertical and horizontal individually. For that we are using a low pass filter circuit and high pass filter circuit. This low pass filter circuit is designed with the help of the resistor and capacitor. The high pass filter circuit is designed with the help of capacitor and resistor. Those resistor and capacitor of low pass filter should be selected in such a manner to produce the vertical synchronizing output that is given as an input to the vertical oscillator. Now we are concentrating only on the vertical sync separator, so we are eliminating the high pass filter circuit. So we have low pass filter circuit in this diagram. So according to the output obtained across the transistor Q2, that output is shown in the waveform of this diagram. So it has a negative output because the input voltage applied to the circuit is a negative VCC voltage. According to the composite video signal, the circuit responds and it will produce an output of synchronizing pulses. The synchronizing pulses consist of horizontal synchronizing pulse, equalizing pulse, vertical synchronizing pulse, and also again it produces equalizing pulses, which is shown in the waveform of this circuit. The waveform consists of horizontal, equalizing, vertical, and again an equalizing pulse at its output. It has two equalizing pulse, one is pre-equalizing pulse and another one is a post-equalizing pulse, which is applied as an input to your low pass filter. The low pass filter will make the capacitor to get charges through the resistor R1. The capacitor charging time will be depends upon the time constant of the horizontal synchronizing pulse and also from the equalizing pulse. The time constant of this horizontal synchronizing pulse and the equalizing pulse will be greater than that of the time constant of this low pass filter. Due to this condition, the voltage appear across the capacitor will be a negligible voltage. So this horizontal and equalizing pulses will be neglected from the low pass filter circuit and there will not be any output produced during this time. Next, a vertical synchronizing pulse will be applied as an input to the low pass filter. The vertical synchronizing pulse consists of 6 continuous pulses that are applied as an input to the low pass filter. This vertical synchronizing pulse will also make the capacitor to get charges through the resistor R1 to produce a serrated triangular wave at its output, which is shown in the waveform in this video. This serrated output obtained from the low pass filter circuit depending upon the input of the vertical synchronizing pulse. The vertical synchronizing pulse consists of rising edge, falling edge, and also the flat surfaces at the rising edge and also at the falling edge. The flat surface at the rising edge width is greater than that of the flat surface of the falling edge width. So this makes the capacitor to get charges during the rising edge, and during the falling edge of the flat surface the discharging will not be a full discharge, which makes the serrated output to be a small discharging. So during the first condition, that is during the flat surface of the rising edge, the capacitor gets fully charged. During the falling edge flat surface condition, the capacitor will discharge for a particular voltage and it again get recharged because of the synchronizing pulse applied at the input terminal. This circuit continues to produce a serrated output at the output terminal of a low pass filter. This triangular wave produced at the output will be depends upon the number of vertical synchronizing pulse applied at the input of your low pass filter. So we have 6 synchronizing pulses that are applied as an input to the low pass filter, which makes the serrated output to be a charging and discharging process. During the next input is nothing but a equalizing pulse. During the equalizing pulse, the serrated output get discharges and the triangular waves comes back to the zero position during this period. This circuit will work in this manner to produce a vertical synchronizing pulse at the output of your low pass filter. This output is given as an input to the vertical oscillator circuit. The serrated output will be a low frequency output which is generated according to the time constant of this circuit. This is the circuit arrangement of your vertical sync separator. Thank you for watching the video. Do comment for upgradation.